Hi everybody. So in this video, we're going to look at running a test of independence using a chi-squared distribution. And if you want to work along with me in this video, you can download a copy of the PDF from my website. I'll leave a link in the description below. So in our question, we're told that a hospital records the number of patients experiencing two different side effects, which we'll call S1 and S2, after receiving a treatment during 3 different shifts. The medical team wants to know if the type of side effect depends on the shift. We've been asked to test at a 10% significance level whether the type of side effect is dependent on the shift. So the first thing we need to do is we need to complete our contingency table by working out these totals. So if we add the 45 and the 18, we get a total of 63. If we add the 55 and the 20, we get a 75. And if we add the 50 and the 12, we get a 62. If we add our columns, the 45, 55 and 50 give us 150, and the 18, 20 and 12 will give us 50. And the total overall is 200. So now we've completed our contingency table, we need to define our hypotheses. The first hypothesis we call the null hypothesis, and this is HO. And this is always that the two are independent of each other. Our second is called the alternative hypothesis. We call this H1. And if in our null we're saying they are independent, in our alternative we're saying that they are dependent. This would mean that the side effect is caused by the shift. So now we'll sketch what the chi-squared distribution would look like. Well, this would be a skewed curve with a peak at the expected value and then tailoring off towards the right. And there's a critical value, which we'll call CV. And this critical value separates the do not reject the null hypothesis region and our rejection region. And we're given in the question this area. This is the significance level of 10%. So we're saying this is 0.1, which means our do not reject has a probability of 0.9. So the next thing we need to do is to find our critical value. And to do this, we need the degrees of freedom. To work this out, we subtract 1 from the number of rows and we multiply this by the number of columns take away 1. So you can see we have 3 rows, so we'll have 3 take away 1, which will give us 2. And then we'll multiply it by the number of columns, and there are 2 columns, so we'll have 2 times 1. This will give us 2 degrees of freedom. So our chi-squared test has 2 degrees of freedom and a significance level of 0.1. So with this information, we can find our critical value using the chi-squared distribution tables in the formula booklet. In our first column, we have the degrees of freedom, and you can see we want 2 degrees. And in the top row, we've got our significance level, and we want 0.1. So to find our critical value, we go across from 2 degrees of freedom to our probability of 0.1, and you can see we've got a critical value of 4.605. Okay? If we go back to our notes, we'll say the critical value is 4.605, and I'll label this on the diagram. So now we need to find our test statistic, and this will tell us whether we fall on the left of the critical value or on the right. If we fall on the left, then we do not reject HO. If we fall on the right, then we do reject HO. And the formula for the test statistic is the sum of the observed values minus the expected value squared over the expected value. So at this point, we need to work out our expected values. And you can see we'll have 6 different expected values. I'll call this cell E11, so the first row, first column. We'll call this one E12, first row, second column, and so on. And to work out the expected values, this has the formula of the row total multiplied by the column total divided by the overall total, and this will be 200. So if we work out the expected results for the number of S1 side effects in the morning shift, I'm just going to need to move this up. Then we'll say the expected value in our first row, in our first column, will be our row total multiplied by our column total divided by 200. And this will give us 47.25. And then the expected results for the second row in the first column will be 75 times 150 divided by 200. And this will give us 56.25. And then the expected in the third row, first column, we'll have 62 times 150 divided by 200. And this will give us 46.5. Then we can check this works. We can add all of these together and we do get a total of 150. So now for the expected value of a first row in our second column, this will be the 63 times the 50 divided by 200. And this will give us 15.75. And then the expected number of observations for our second row, second column, we'll have 75 times the 50 divided by 200. And this will give us 18.75. And then finally, the expected for the third row, second column, we'll have 62 times 50 divided by 200, which works out as 15.5. We'll add all of these together and we do get 50. We'll add our rows and we get 63, 75 and 62. Again, with an overall total of 200. And then to work out the test statistic, we need to find the square of the observed value, take away the expected value, and then divide that by this expected value. So we'll use the fraction. We'll have the 45 minus the 47.25 squared over 47.25. And this will give us 0.107. So we'll move on now to the 18 and the 15.75. And we get 0.321. We'll move on to the 55 and the 56.25. 0.028 to 3 decimal places. We'll move on to the 20 and the 18.75. And we get 0.083. Then we'll have the 50 and the 46.5. And we get 0.263. And then we'll look at the 12 and the 15.5. And we get 0.790. So now we need to add up each of these. And we get a test statistic of 1.592. Okay? And I'll show this on our distribution, which will be about here. Now you can see that this clearly falls in the do not reject region. So because our test statistic is less than the critical value, we'll say therefore do not reject HO. The type of side effect is not dependent on the shift. Okay? Well, thank you very much for watching. I hope that's given you a clearer idea on how to test for independence using the chi-squared distribution. If you found that helpful, please like and subscribe, and you can download the full lesson and a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.